Advanced rotations. Suppose this is my tree for which every node is currently balanced, then I call insert 18. Well, 18 is less than 25, greater than 15, and less than 20. So 18 would go right here. Now, next I check the grandparent to see if this assertion became unbalanced. We see that it has not, so I go on and check the ancestor, the great-grandparent, and I see that 25 has become unbalanced. The height of the left subtree is 3, right side is 1. Thus, we need to rebalance it. However, the question is, do I treat this as a left-left situation, or do I treat it as left-right? Well, the answer to that depends on the child of the unbalanced node. We need to determine if this node is heavier on the left side or heavier on the right side. Clearly, this node is heavier on the right side, so we're going to call this situation left-right heavy. And in a left-right heavy situation, the A, B, and C nodes perform the exact same actions that they do in a normal left-right situation. The question is, what will these extra nodes do? What do nodes 10, 18, and 30 do? And the answer to that is they will keep the same role unless one of the rotations causes the A node, B node, or C node to take their role. And what I mean by that is, with the first rotation, we know that A drops down and becomes the left child of B. So in this situation, the only node whose role got taken was node 18. So what we do with it is that we're going to move it from the right side of that subtree to the left side of that subtree. So now 18 goes from being someone's left child to another node's right child. Then next we do the second rotation. We're going to make B the root. And in this case, nobody's role got taken, so no other action needs to be done, thus completing this operation. Now, suppose this were my tree, of which all the nodes are currently balanced. Then I call remove 30, thus getting rid of node 30. All right, now I'll check my root node and I see that this node has become unbalanced. But the question is, how do we rebalance it? Do we treat this as a right-right situation, or do we treat it as a right-left situation? Once again, this will depend on the child of that unbalanced node. We need to determine if it's left-heavy or right-heavy. We clearly see it's left-heavy, so we're going to treat this as a right-left-heavy situation. And like we discussed, in a right-left-heavy situation, the nodes A, B, and C are going to do the exact same actions that they do in a regular right-left situation. The question is, what happens to the other nodes? What happens with 35, 45, 55, and 65? Well, let's carry out the first step. The first step, C becomes the right child of B. In this case, the only node whose role got taken was 55. So what we do with 55 is we're going to move it over to the other side. 55 will go from being a right child to a left child. Next, we need to make B the root. In making B the root, A will become the left child of the B node, thus taking 45's role. So what do we do with 45? Once again, we take that node and we're going to move it to the other side. 45 will go from being a right child to a left child, thus completing the operation. So, in summary, suppose we refer to the child of the unbalanced node as node X. If X is a left child and is heavier on the left side, or if both sides are equally balanced, then we treat it as a left heavy scenario. If X is a right child and is heavier on the right side, or equally balanced, we treat it as a right heavy scenario. If X is a left child but is heavier on the right side, treat it as right heavy. If X is a right child and is heavier on the left side, treat it as right left heavy.